I have one last, I was going to say trig property, no, one last logarithm property to show you. So let me pick a suitably festive color for this last property. So let's say that just, I don't know, x to the n is equal to a, right? Nothing fancy there. Well, that's just that's another way of saying that log base x of a is equal to n, right? That's the exact same. This is just the exact same way of writing the exact same thing, just with, one's with a logarithm, one's with an exponent, right? These imply the same thing. But what we could do is if n is actually equal to this expression, we can, like I did a couple of videos ago, you could just substitute this for n. So we could write x to this thing log base x of a, and we could set that is equal to what? A. Fascinating. So now what I'm going to do, and actually this is going to get pretty messy, is I'm going to raise. Actually, let me write this with a little more space. Undo, 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 undo. Oh, I can't keep undoing. Anyway, so let me write it down here with more space because I'm going to do something fancy. So ignore this. So if I said x to the log base x of a, that equals, and you'll see why I'm giving you so much space right now, equals a. Now what I want to do is I want to raise both sides of this equation to 1 over this exponent, right? So I'm going to raise that to 1 over log base x of a. If I do something to one side of the equation, I have to do it to the other. So that's equal to a to 1 over log base x of a. I know this is quite daunting already, but you'll see where I'm going, and hopefully nothing I've done is completely non-intuitive, right? I just, this expression is just another way of writing this expression, and I substitute for n, and now I'm raising both to this exponent, and you'll see why I'm doing that. Well, if you're raising something to an exponent and then you're raising that to an exponent, you just multiply the two, right? So they cancel out because this will be in the numerator and this will be in the denominator. So that gets us to, this x to the 1 power, right? Because log base x of a over log base x of a is equal to 1. So that's the same thing as x is equal to a to the 1 over log base x of a. You're probably saying, Sal, where are you going with this? And I will show you shortly. So we could just replace a with another variable, right? I could also write x is also equal to b to the 1 over log base x of b, right? Nothing strange there. I just, the same exact thing I did with a, I could do with a. With the same thing I did with a, I could do with b. So, well, I've written these two expressions. Let me equal. I said x is equal to both of these things. So let's set them equal to each other. So we know that a to 1 over log base x of a is equal to b to the 1 over log base x of b. So what can we do now? Well, let's raise both of these. Actually, I'm running out of so much space. Let me clear this and go to the next page, or go to another page. Whoops. Clear image, invert. So what did I just write? I said that because I need a lot of space for what I plan to do. So I said a to the 1 over log base x of a. Well, that equals b to the 1 over log base x of b. And hopefully you're satisfied with that. Now let's raise both of these sides to the log base x of b power. So I'm going to raise this to the log base x of b power. And hopefully you'll see why I'm doing this. Well, on this side, they'll cancel out, right? Because this becomes a numerator. That's the denominator. And on this side, you get a to the, this becomes the numerator, right? Because we just multiply the exponents. Log base x, that little dot is an x, of b over log base x of a. And what does that equal? Well, that equals just b, right? Because this over this is 1. This b to the 1. That equals b. Now, let's write this entire thing as a logarithm. A to this thing is equal to b. That's the exact same thing as saying that the logarithm base a of b is equal to this thing. Is equal to the log base x of b divided by the log base x of a. This might seem confusing and might seem daunting, but we're actually going to do a lot of examples of this. And this is probably the single most useful identity, I guess we could call it, if you're using a calculator. Why? Because your calculator only has two bases. It either has log base, base 10 or base e, right? So if and most of them, when you press the log button on your calculator, that it assumes log base 10. So if I gave you a problem where I wanted to know, what is let me switch colors because this is my example color. If I wanted to say what is the log base 7 of 3, right? Who knows? 7 to what power is 3? And there's no easy way on most calculators to do this. Well, you can use this identity that this is the same thing as the log base 10 of 3 divided by the log base 10 of 7. And these are very easy to calculate on your calculator. You just type 3 and press log, and it'll give you this number. And you press 7 and click on log, and it'll give you this number. And then you're done. So hopefully you're satisfied that this is true, and you have a little bit of an intuition of how to use it. And I'll make a bunch of videos now on actually how you can use these logarithm properties. I just wanted to get it out of the way so that you're satisfied with it, that they are true. I'll see you soon.